This is another problem from our electrostatics practice test. So this is about induction, which you had homework at some point to read about this, but I don't really think you all did that. So it might help to go back and read that bit. But basically they're saying, hey, got these are conducting spheres. They're touching each other at the moment. Bring in this rod. The rod is brought the same distance from each set of spheres. They're initially in contact, but then are separated while the rod is still in place. That's important. And then the rod is removed. Rank the net charge on each sphere from most positive to most negative after the spheres have been separated and the charged rod removed. Okay, so the idea behind induction is that if you have a conductor, the electrons are free to move along the surface of that conductor, whatever. They're allowed to move around, not a problem. So they're going to. So, for instance, for A and B, I bring in a positively charged rod. Well, electrons are attracted to that. So the electrons are going to kind of crowd over as close as they can get to that thing. So you're going to get a bunch of negative charge kind of, I don't know, ganging up over here. And that negative charge had to come from somewhere. Where it came from was this whole chunk of metal, A and B together. Well, that means that somewhere on the other side, for instance, there was something that had a net zero charge that now is lacking electrons that it used to have. So that means it's left with a positive charge over here. I should use a different color. Use a different color. Here we go. Positive. Okay. Okay. Now, if we separate them while they are distributed like this, well, these electrons can't go back to the vacated area on the right. So when we do remove the rod, the electrons are no longer enticed, but they can't flee back to their home. They're stuck. So we just end up with a negative charge evenly distributed on the A, and a positive charge evenly distributed on the B. So A is going to end up negative, and B is going to end up positive. Now when we look at C and D, something slightly different happens, or actually no, it doesn't, but the way that they are configured means that when we split them, something different is going to result. So when the electrons are attracted to the rod, you end up with, electrons along this side. Oop, it froze. What happened? Okay. Just ignore that little mark, okay? Ends up over here. And where they came from was over here. So we're left with positive on the other side. Okay? But the thing is, when we separate, or we cut them in half, and we remove the rod, these green electrons are just going to redistribute nice and evenly, so you're going to end up with zero charge because they were removed from the same sphere, and then they're going to go back to the same place. So these two are going to end up as zero once you remove the rod. This one's negative, that one's positive. Okay, this one, same thing happens as the top, except now it's a negative rod, which means the electrons are actually going to flee. They're going to try and get to the far side, which means they vacated the area over here, leaving naked protons, so positive charge. So when you separate them, a positive charge is left on the E, and a negative charge is left on the F. Okay, so this is charging by induction. One way to do it anyways. Now you have to be very careful. If we had removed the rod before separating these, so they were still touching when we moved the rod, the electrons would have just distributed back to both spheres having a net zero charge. Okay, so it's very important that whatever you're using to induce the charge remains there while you cut off the path of retreat for the electrons. So anyway, when I go to rank them, most positive is going to be B and E. It doesn't matter if you do EB or BE. There's no real difference. Okay. Zeros are go in the middle, and then negatives go at the end, A and F.